Welcome back, everybody, and it's Kistner again, and we are looking at section 2.7 today. That will be on page 58 in your student companion. If you don't have a student companion, go ahead and start writing this down on a separate sheet of paper, and you will probably need a calculator today as well, a graphing calculator. All right, so we're talking about linear quadratic systems. We've talked about linear systems, a system of linear equations is another way to say that before, where the solution was where they intersected. The two lines intersected, wherever that point was, that was our solution. We have an x and a y. Well, linear quadratic systems will be the exact same thing. It'll be the graph of where a quadratic, a parabola, crosses a line. And we will have the same kind of solution. Where they cross is our solution. So to determine the number of real solutions of the system, there are two ways to do this that I am going to show you. The quick way is to simply set them equal to each other and solve. So if we do that, if we set these equal to each other and solve, because they're both equal to y, we substitute in, we will get 3x squared equals 3x minus 2. And remember, for a quadratic, we always want it equal to 0. So I'm going to bring everything over and get 3x squared minus 3x plus 2 equals 0. And we will now solve this. You can use the quadratic formula. You can plug it into your calculator. You can try to factor it. I'm going to use the AC method and get x squared minus 3x plus 6 equals 0. And it factors into x and x. And is that going to be... I don't think that's going to factor pretty cleanly, is it? So right here, I'm starting to see that this isn't going to factor clean. There's nothing that multiplies to get 6 and equals negative 3. So what I'm going to do is I'm going to go back and do the quadratic formula. So I'm going to say x equals, well, first off, that thing I'm going to check is what is b squared minus 4ac? We learned that last video, that if b squared minus 4ac is less than 0, we don't have a real solution. I don't know why my mouse is jumping around like that, but we'll try to fix it. B squared. So once your calculator is in front of you, we're going to go into y equals, and we're going to type in both of these functions, 3x squared in one of them, and 3x minus, not that symbol, minus 2. And then we just make sure we're zoomed standard, zoom 6, and we look. And we should be able to tell if these things are ever going to cross. They never hit, so we know there's no real solutions. If they had crossed, we would have found where they crossed. So let's go to one where they actually do cross. Hopefully I can find one. Well, this one says solve each system by substitution. That was what I was trying to do last time. Y equals this. So I'm going to plug this in for this y. So it's going to be 2x minus. And I'm going to write down what y equals. It equals 2x squared minus 6x minus 8. And all of that is equal to 16. And now I combine like terms. That's 2x minus 2x squared plus 6x plus 8 equals 16. So what I really have is a negative 2x squared plus 8x plus 8 equals 16. I'm going to subtract the 16 from both sides. And get a negative 8 equals 0. And from here, you can use the quadratic formula. So now we go quad formula, and that will give us our solutions. Okay, I'm not going to take the time in interest of keeping this video short. If you would like for me to work this out, please ask me next time you see me, and I will work it out. And we will definitely do B in class as well. But from here, you do the quadratic formula, what we learned last time, plugging in B, A, and C, and it should give you your solutions, where these two lines cross. Now, Andrew kicks a ball up a hill for his dog, Leica, to chase. The hill is modeled by a line through the origin. The path of the ball is modeled by the quadratic function shown. How far does the ball travel horizontally? and how far must Leica run up the hill to catch it. So the ball traveling horizontally will be this distance. You can see that. This is the horizontal distance because this is where it crosses. This is where the ball lands on the hill. So I want to know the x distance. So basically it's saying solve for x. And then I also want to know the y distance because that'll be how far she has to run up the hill. Okay? Now, well, sorry, run up the hill. We actually need to know this. This is going to come into play next time I see you guys in class. But what I do want to show you is you can do this on a calculator. So let's type in these two equations to the calculator. I have to look again. It's negative 0.5 x squared plus 6x. Negative 0.5 x squared plus 6x. And the other one is 0.5x. Okay. So I'm going to graph both of these. And it should show me a picture similar to what is here. We're obviously just seeing the first quadrant. Oh, I'm going to have to zoom out a little bit to see this intersection point. It's going to be way over here. So because we can't see this, I'm going to make my window match their window. So they go from 0 to 30. If it's going by 5, 5, 10, 15, 20, 30. They're actually going by 2.5s here, aren't they? Yeah, they're going by 2.5s all the way up to 30. Is that right? 2.55, 7.5, 10. Yeah. Okay, and they're going up the same way on the y. So what we're going to do is we're going to change our window. Our x min should be 0 because that's where they start theirs. Our x max should be 30 because that's where they stop theirs. And the x scale is where we change what they're going by. And in this video, they're actually going by 2.5s on their scale. I'm just trying to make mine match theirs. On the y-axis, it's the same way. Y min is 0, y max is 30. There's 20, actually, if I'm looking at it now. You can tell up here, it only goes to 20. And they're going up, once again, by 2.5s. So now if I graph, I should see what they see. There's the parabola of the ball thrown, and here comes the line. Maybe. There it is. And I want this location right here. I know that's what I want. I want the x-coordinate of that. I want the horizontal distance. So we've used the second trace menu multiple times to find the value, the 0, the minimum, the maximum. I want to know the intersection point. So I'm going to go 5, intersection, and move my cursor until I see it. I don't know where it is. It's being really weird. Okay, there it is. For some reason, it's way up there. I don't know why I couldn't see it. But now I'm going to move it down. You want to put both guesses, the first curve and second curve, really close to this. And it still got it for me. It intersects at 11, 5.5. So how far must Leica run up the hill? Well, we know this point is now at 11, 5.5. So let me write that in. This point is at 11, 5.5. So that is this distance and this distance. I will talk in class how you find how far she had to run up the hill. We'll talk about that, okay? But what I wanted you to see is your calculator will find the intersection point for you as well by doing that second trace option. We will solve this in class as well. I'm going to do a lot of these in class together. So I'm going to, right now, stop the video early. Last video was a little bit longer. This video is a little bit quicker. Let me stop this, and I will talk to you guys next time. This is Kistner out.